The U.S. Air Force has been trying to retire the aging A-10 Thunderbolt for years. Freeing up that budget would allow them to buy more fifth-generation stealth fighters like the F-35. But there is one specific critical choke point on the map that forces the military to keep this 50-year-old analog jet in the sky. That choke point is the Strait of Hormuz. It is a highly congested, literal coastal environment. The geography here is defined by extremely tight waterways and a complex network of hidden coastal inlets. Those inlets provide perfect cover for a specific asymmetric threat. The Islamic Revolutionary Guard Corps, a primary branch of the Iranian armed forces, operates swarms of small, highly agile attack boats that can emerge from the coastline, strike a target, and vanish quickly. A $100 million stealth fighter like the F-35 struggles against this type of swarm. Modern stealth jets fly high in the atmosphere and at extreme velocities, making it incredibly difficult for their pilots to visually track small, erratic boats skimming across the waves. The A-10 was built with the exact opposite design philosophy. It operates right above the surface and can slow its flight speed down to a crawl. This low and slow approach allows the pilot to visually identify hidden targets and maintain a persistent line of sight. In this environment, the A-10 does not operate alone. It serves as the heavy hitter in a layered tactical network, flying directly alongside Apache attack helicopters. Together, they form a low-altitude net to hunt down boat swarms and intercept incoming attack drones. Speed and altitude are usually the greatest advantages a military aircraft can have, but over the Strait of Hormuz, they are liabilities. To counter dozens of small boats hiding in coastal inlets, the military needs a slow, persistent overwatch. Operating at those low altitudes introduces massive risk. When you fly close enough to the ground to visually track a small boat, you are also flying directly into the range of small arms fire and man-portable air defense systems, which are shoulder-fired anti-aircraft missiles. To survive that barrage, the A-10's airframe is constructed primarily from aluminum alloys. The skeleton relies on multiple independent beams running along the length of the fuselage and wings. If one beam is severed by enemy fire, the structural integrity holds. But the core protection mechanism sits right around the pilot. The cockpit is encased in a massive, solid shield, officially known as the bathtub. This tub is forged from 1,200 pounds, or about 540 kilograms, of titanium armor. It wraps around the lower half of the cockpit, shielding the pilot and the plane's redundant flight systems from ground fire. The A-10 takes direct hits from heavy anti-aircraft fire and keeps flying. That is a level of physical punishment the military refuses to test on a fragile stealth jet. The A-10's engineering revolves around a single piece of hardware, the massive GAU-8 Avenger cannon. In a very literal sense, the entire aircraft was designed to accommodate the gun. The Avenger is a 30mm Gatling cannon. Dual hydraulic motors produce 77 horsepower to rotate its 7 barrels around a central axis, firing sequentially to allow rapid cooling between shots. At full speed, it cycles 3,900 rounds per minute. These are not standard rounds. A single 30mm bullet is larger than a human hand. Packed with a depleted uranium penetrator, one of these armor-piercing incendiary rounds can punch straight through 38mm of solid steel from a kilometer away. Feeding thousands of these massive rounds into the gun requires a double-ended, linkless feed system. Instead of ejecting the heavy spent casings out of the plane, the system cycles the empty brass back into the drum magazine. This prevents the aircraft from suddenly shifting its center of gravity mid-flight. But the gun creates an extreme physics problem. Firing the Avenger generates 10,045 pounds of recoil force pushing backward. For context, that is more force than the forward thrust generated by one of the A-10's own jet engines. If the gun were mounted perfectly straight, that recoil would tear the plane off its target path. To fix this, engineers mounted the cannon slightly off-center to the port side. This offsets the recoil forces, preventing the nose from yawing left or right when the pilot pulls the trigger. By solving the immense physical strain of the recoil, the Warthog becomes a stable, flying artillery piece. It delivers a volume of armor-piercing fire that modern multi-role fighters simply cannot match. That off-center nose cannon is paired with another highly distinct visual feature, the massive twin engines mounted completely above the fuselage. Placing the engines high up protects them during takeoff. Coastal airbases and conflict zones are often damaged and littered with foreign object debris, like loose rocks and metal fragments. A high mount ensures the intakes don't vacuum up that debris and destroy the turbine blades. Those engines also offer a thermal advantage. The TF-34 produces a relatively cooler and slower-moving exhaust compared to traditional jet engines. This lower temperature minimizes the A-10's infrared signature, making it much harder for heat-seeking missiles to lock on. If an enemy radar system does achieve a lock, the plane relies on a network of warning receivers positioned on the nose, on the wings, and the tail. These sensors provide 360-degree detection, instantly alerting the pilot via the heads-up display to deploy flares and break the missile's tracking signal. All of these systems, the armored bathtub, the high-mounted engines, the radar warnings, exist for one reason: to keep the A-10 circling above the battlefield long enough to use its massive fuel capacity. With up to 11,000 pounds of fuel distributed across 4 self-sealing tanks, the A-10 possesses immense loiter time. It can circle the Strait of Hormuz for hours, waiting patiently for enemy boats to make a mistake and leave their hidden inlets. When they do, the pilot arcs into a dive. Beyond the cannon, they can release Mark 82 gravity bombs equipped with global positioning system kits. The bomb inherits the forward velocity of the plane the moment it drops, gliding precisely onto the target's coordinates. The Air Force may want a sleek, modern fleet of stealth fighters, but as long as fast, agile boats threaten narrow coastal waters, the military will continue relying on a slow, heavily armored predator that can take a hit, hold its ground, and keep firing.